Exercise 3, question number 1. Determine the gravitational potential energy U of the Earth due to the Moon only, and then B due to the Sun only. Okay, so for this question, we have to calculate U, okay, gravitational potential energy. So we have to use formula U equals negative GMM over R, where R is the distance between the point and the point mass. Okay, distance between the point and the point mass. Okay, so let's say this is the Earth. Okay, this is the Earth, and then this is Moon. Okay, Earth and Moon. So Moon orbiting Earth. Okay, Moon orbiting Earth. Okay, so radius of the Moon orbit around the Earth is given. This one. Okay, radius of Moon orbiting Earth is actually the distance between the point and the point mass. Okay. Okay, so we have to substitute value of G, where G is the gravitational constant. It is 6.67 times 10 to the power of negative 11. And M is the mass of the Earth. Alright, it is 5.98 times 10 to the power of 24. And then M is the mass of the Moon. It is mass of the Moon. Okay, mass of the Moon. What is it? Mass of the Earth, radius of Earth, mass of Sun, radius of, and this one. Okay, mass of Moon is 7.35 times 10 to the power of 22. Okay, over R. Okay, R is distance between the point and the point mass. So it is given radius of the Moon's orbit around the Earth. So this one is also the distance between the point and the point mass. To substitute the value, it is 3.84 times 10 to the power of 5 kilometer. So you have to convert from kilometer to meter. So it is times 10 to the power of 3 meter. So it will be 3.84 times 10 to the power of 8 meter. Okay. So the answer is 6.67 to the power of negative 11, 5.98 to the power of 24 times 7.35 to the power of 22 divided with 3.84 to the power of 8. So it is equals negative 7.63 times 10 to the power of 28 joule. Okay, negative 7.63 times 10 to the power of 28 joule. Okay, this one is for A. Okay, gravitational potential energy of the Earth due to the Moon. And then B. Okay, B. Okay, for B, alright, it is gravitational potential energy of Earth due to Sun. Okay, so let's say this is the Sun. Okay, and then this is Earth. Okay, so Earth orbiting Sun. Earth orbiting Sun. So radius of Earth orbiting Sun is given. It is 1.5 times 10 to the power of 11 meter. So this one is also the distance of the point and the point mass. Okay, this is radius of Earth orbiting Sun is also the distance between them. Okay, so again we can use formula U equals negative G mm over R. Okay, so substitute G and then M. Okay, mass of the Sun 2 times 10 to the power of 2 times 10 to the power of 30 kilogram, and then mass of Earth 5.98 times 10 to the power of 24 divided with distance between them. It is 1.5 times 10 to the power of 11 meter. Okay, so 6.67 to the power of negative 11 times 2 to the power of 30 times 5.98 to the power of 24 divided with 1.5 to the power of 11. So it is equals 5.32 to the power of 33 joule. Okay. Negative 5, negative and negative. Okay, negative 5.32 times 10 to the power of 33 joule. Number 2, if a satellite of mass, satellite of mass 800 kilogram falls from a height at 400 kilometer to the surface of Earth, what is the loss in gravitational potential energy? Okay, what is the loss in gravitational potential energy? So it is the delta U. Okay, it is the delta U. Alright. Okay. So delta U is equals U final minus U initial. Okay. Where U final is negative G mm over R final. Okay. And U initial is negative G mm over R initial. So satellite falls from height 400 kilometer to the surface of Earth. Okay, so it is like this. We have Earth here. Okay, Earth, and then this is satellite. Okay, initial position. Okay, it is at height 400 kilometer to the Earth's surface. Okay, initial position, and then it falls to the Earth's surface. Final is here. Okay, final at Earth's surface. Okay, final at Earth's surface here. Okay, this is final position. Alright. Okay. So for this one we can factorize. Okay, we can factorize negative G mm, okay, 1 over Rf, okay, minus 1 over Ri. Okay, so substitute G. G is gravitational constant. It is always 6.67 times 10 to the power of negative 11. And then M is the point mass. Point mass here is the Earth. Okay, satellite orbiting Earth. Okay, satellite orbiting Earth. Okay, so M besar tu adalah point mass. Okay, so boleh substitute mass of Earth. Mass of Earth is 5.98 times 10 to the power of 24. And then small letter m tu adalah mass of test mass. So test mass dalam ni adalah satellite. So mass of the satellite is given. It is 800 kilogram. Okay, 800 kilogram. And then 1 over Rf. Rf, okay, distance. Okay, Rf is distance final position to the point. Okay, so point is to the Earth's center. Okay, so Rf is the radius of Earth. Okay, radius of Earth. So radius of Earth is 6.38 times 10 to the power of 6. Okay. Okay, minus 1 over R initial. Okay. R initial is the initial distance. Initial distance from the test mass to the point mass. So this one. Okay. Okay, I use this one. Sampai sini lah. Okay, dia mesti sampai center. Okay, so yang dia bagi ni adalah height. Sampai a surface saja. Okay, jadi R initial so R initial is height plus radius of Earth. Okay, height is 400 kilometer. So you have to convert to meter. Okay, 400 times 10 to the power of 3 meter plus radius of Earth. Radius of Earth is 6.38 times 10 to the power of 6. It is given. Okay, in the question. So the distance initial is 400 to the power of 3. Okay, plus 6.38 to the power of 6. So it is equals 6.78 times 10 to the power of 6. Okay, so we can substitute the value now. Okay, 6.78 to the power of 6. Okay, this one is the distance initial. Okay. So it is equals to negative 2.95 times 10 to the power of 9 joule. Okay. Number 3, the moon has mass of 7.35 times 10 to the power of 22 kilogram and radius of 1,740 kilometer. Determine the gravitational field strength at its surface on moon surface. Okay, gravitational field strength is the Ag. Okay, so formula for Ag is Ag equals Gm over R squared, where G is the gravitational constant. Okay, this value, and then M is the point mass. So for this case, point mass is the moon. And then R is the distance between the test mass and point mass. Okay, test mass and point mass. Okay, so test mass dia ada dekat mana? Kat moon surface. Okay, jadi so dia mesti sampai center lah. Okay, so R ni akan jadi radius of moon. Okay, so substitute G 6.67 times 10 to the power of negative 11. M is the mass of the moon. 7.35 times 10 to the power of 22. And then R is the radius of the moon. 1740 kilometer. So kilometer kena convert kepada meter. So times 10 to the power of 3. Jangan lupa square. Okay, ni square kat sini. So kita akan dapat answer 6.67 to the power of negative 11 times 7.35 to the power of 22. Divide with 1740 to the power of 3 squared. So the answer is 1.62. 1.62 times, okay, 1.62 and the unit is ms negative 2. Okay, so this is gravitational field strength on moon surface. Okay, at moon surface. Okay, B, a probe of mass 100 kg is dropped from a height 1 km onto the moon surface. Calculate its change in gravitational potential energy. Okay, so gravitational potential energy is U. Change in gravitational potential energy is delta U. So delta U is U final minus U initial. Okay, initial position of the probe is at height 1 km. Okay, so this is initial position of the probe. And final position of the probe is on the moon surface. Okay, on the moon surface. Okay, so this is the probe and this is the moon. Okay, so this is the initial position. Okay, so it is dropped onto the moon surface. Okay, so final position of the probe is here on moon surface. Okay, okay, this is the probe. Okay, probe. Probe ni adalah spacecraft spacecraft. Okay, so dia daripada ketinggian dia ni sampai Earth surface adalah 400 km. Sorry, 1 km. Okay, 1 km. Okay, 1 km at height 1 km from moon surface. Okay, and then they drop sampai dekat moon surface. Okay, so ini sampai sini je lah. Okay, 1 km ni sampai moon surface saja. Okay, the U is U final minus U initial. U final is negative G mm over R final. Okay, and U initial is negative G mm over R initial. Okay, so kita boleh factorize negative G mm 1 over RF minus 1 over Ri. Okay, so substitute G, gravitational constant. And then mass of point mass is the mass of the moon. Okay. Mass of the moon is given and the question ini 7.35 times 10 to the power of 22. 7.35 times 10 to the power of 22. And then small letter m is mass of the test mass. So test mass dalam soalan ni adalah prop. Okay, prop. Prop yang diubah daripada ketinggian 1 km ke atas permukaan moon. Okay. So mass of the satellite, mass of the prop is 100 kilogram. Okay, so substitute. Okay, our final, final position dia adalah dekat atas permukaan bulan. Okay, on moon surface. Okay, R dalam formula U equals negative GMM over R adalah distance between the point and the point mass. Okay, point and point mass. So dia dekat position ni, so point mass ni mesti sampai center. So R final dia adalah radius of moon. Okay, R final dia ada radius of moon. So radius of moon is given, right? Okay, it's given 1740 kilometer. Okay, 1740 kilometer kena convert kepada meter. Okay, R initial dia ada kat mana? Dia ada dekat 1 kilometer. Okay, above the moon surface. So R initial dia adalah height plus radius of moon. Okay, height 1 kilometer convert kepada meter. One kilometer convert kepada meter. And then radius of moon. Okay, radius of moon is 1740. Okay, kilometer pun ini pun kilometer, kena convert kepada meter. Okay, betul tak? Radius dia 1740 kilometer. Okay, so boleh substitute, boleh kira lah. Okay, boleh kira 1 to the power of 3 plus 1740 to the power of 3. So it is equals 1.741 times 10 to the power of 6 meter. Okay, so dah boleh substitute kat sini. 1.741 to the power of 6 meter. Okay, so boleh dapat answer. So it is equals negative 1.62 times 10 to the power of 5 joule. Okay, negative 1.62 times 10 to the power of 5 joule. Okay.